Don't worry, I'm not a get out there.
My biggest problem with this game, other than I feel like it's pretty rising danger, is friends are turning against me.
Oh my God, Trey got AJ.
Was AJ mad?
I almost got Scott, bro. Yeah.
Only a couple of them.
Wait, Aiden, listen to this.
Who is missing?
Yeah, like actually, as in
Who was it?
All right, friends, here we go.
and I fixed it all.
Whatever. She just got a lot. I just asked
We
her.
are ready for number 4
Whatever.
and 9.2.
I doubt her no backseat.
Is there a last second?
Why is your last so
No, you're just gonna be.
I thought I didn't realize it was further than I did on hers.
All right,
I think it's
quiet. Hey, guys, time to focus. Time to focus, right?
Yeah.
Some more louder.
I used to do nothing on that.
You've been doing nothing
I
on
just
that.
I just watch movies in the first my first
But that's not happening.
That's not happening, we're gonna work.
Oh, yeah.
It was a good movie. Dude, me and this boy are gonna work you
Oh, I
out.
think we do. It's like a first plus 10.
We are going to
But I'm pretty sure it's
find the probability of rolling a die 5 times and getting exactly 1 3. Now, I want you to think about something for a second. When you roll that die, you are either going to get a 3 or you are not going to get a 3. Would you agree with that? Oh, going to get a 3, not get a 3. Okay, so what is the probability
1 in 6.
of a 3? That would be 1 in 6. And what is the probability of not a 3?
5, 6.
5, 6. Everybody agree with that? Okay. Now, we want to roll this die 5 times. And get 1 3. So in other words, I want that 1/6 probability to happen once, right?
Yeah.
And then the 5/6 probability to happen the other 4 times. Now, what have I not accounted, are you with me so far? Does that make sense?
Yeah.
Why'd you put
What
it
have
here?
I not accounted for?
Roll 3 multiple times. She wants the 5.
No, actually, that's in there, but when do I roll the 3? Do I have to roll the 3 first?
No.
I just, somewhere in there, I need to roll a 3. So here's the situation, guys. You have, if I wrote out the probabilities, they look like this. So this would be if I rolled the 3 first. And then, not 3, not 3, not 3, not 3. But it could also be 5, 6, and then 1 6, and then 5. You see what I'm saying? I'm trying to explain that 1/6 can be intermixed anywhere in any of my rolls. Okay? Now, how many ways can I arrange? I'm arranging these guys right here. These are what I'm arranging. How many ways can they be arranged?
5.
Why 5? You're right, but why 5?
Because there's
because the 1/6 could be first, or second, or third, or fourth, or fifth, right? So there are 5 different ways I could write out this line of numbers. So that has to be multiplied by 5. And that, whatever that is, will be the answer to the question. So 5, 1/6 times 5/6 to the 4th power. So 0.40188.
Yeah.
So about, now, 0.401, yeah, 88. So there is about a 40% chance that you'll get only 1 3. Now, I want to show you how this ties into, because I know we haven't had class for a while, and you're probably, maybe you've forgotten what we were talking about before, but this is like totally different than what we were talking about before, except it's really not different. I want to go back to Pascal's triangle. You remember this from the other day?
Yeah.
All right, I want to go back to here. And I'm interested in the 5th row of the triangle because the 5th row represents 5 tosses of my die. Okay? Now, this guy right here, that 1, represents getting all 3s. This represents getting 4 3s and 1 knot. First, this is 5 3s. 5 3s. Then I could get 4 3s and 1 knot. There's 5 ways to do that. You just did it backwards, but that's that. This would be 3 3s and 2 knot. 2 3s and 3 knot. 1 3 and 4 knot. Right there it is. Now you saw it by writing it out, and since there were only 5, it was easy to kind of visualize. These would be a little harder. So instead of writing it all out, whenever an event is binary, that is this or this, that's it, 2 options, you can use Pascal's triangle. Okay, you can use Pascal's triangle. The first number, let's say you're taking a quiz that has 4 questions. 4 questions. You're guessing on the quiz. This would be 4 correct. 4 questions, 4th row. This would be 4 correct. What would this be? 3 correct, 1 wrong. This would be 2 correct, 2 wrong, and so on down the line. So whenever you're either right, wrong, 3, not 3, true, false, whatever it is that's binary, you can use the triangle to tell you how many ways you can get what you want. So in our problem, there are 5 ways to get 1 3. Then I've got to multiply by the probabilities of that. So 1 3, 4 not 3s, because I have a total of 5 rows. Let's look at the next one. No 2s. No 2s. So I'm still rolling my die 5 times. So I'm still looking at the 5th row of the triangle, so right here. When I roll that, I'm either going to get a 2 or I'm not. Those are my 2 things. 2, not 2. Where on the triangle would I find no 2s? Well, this would be 5 2s. Yeah, Tyler, you're right, it's 1. This would be 5 2s, 4, 3, 2, 1, no 2s right here.
Wait, why do we use that bottom row?
Because it's the 5th row and I'm rolling 5 times.
Oh, okay. So if you roll 4, then it's the same.
That's what I did here.
What about 6?
I would use the 6th row in the triangle. The triangle doesn't stop.
Oh, I thought it did. Sorry.
Okay, So, let's look at this one more time. This number, remember, I'm gonna get a 2 or not get a 2. All right, those are my two things. So this represents getting a 2 5 times. So getting 5 2s. And no not 2s. This is 4 2s and 1 not. These are like your exponents when we did the binomial expansion. This is 3 2s, 2 2s, 4 2s, no, 3 2 1, no 2s, and 5 not 2s. So that's the number that I want, 1. What is the probability of getting a 2?
1/6.
1/6. And I don't want any of those, so I put a 0 on that. I don't want any of those. No 2s. What is the probability of not getting a 2? 5 6, and I want 5 of those. So the answer would be oh gosh, I think it's the same number. It is 0.40188. Okay. No more than 1/4. So forget the triangle, forget probability for a second. What does that mean?
It doesn't have to be a 4.
No more than 1/4. No, I think I know what you
You
mean.
can have 1 or 0.
You can have 1 or 0. So remember, we're rolling 5 times. So we're rolling 5 times. So I can get 1 4, or I can get no 4s, right? Now, 1 4 would mean 1 4 and 4 not 4s. I'm rolling 5 times. So one's a 4, the other 4 are not. No 4s would be, okay, no 4s and 5 that aren't 4s. Now, what's the probability of getting a 4? 1/6. Anytime you're rolling a die, it's gonna be 1/6, and you want 1 of those. What's the probability of not getting a 4?
5 6.
5 6, and you want 4 of those. Okay, now you need to know how many ways that can happen. So that is 1 4. So when you look at the triangle,
5.
the first number in the triangle represents
4 on all 4s.
all 4s, 5 of what you want. So 5 4s, 4, 3, 2, 1 4.
Yep.
So this is the number I want. So I put a 5 in front of that because there's 5 ways to do that. Now what about no 4s?
1.
Well, that would be this number. Would you agree with that?
Yeah.
So that's gonna be a 1, and then the probability of a 4, I don't want any of those though, so it's 1/6 to the 0. And then 5 6 to the 5th, because I'm rolling 5 times. Now, since this is an either or situation, what am I gonna do with these two numbers?
Add.
I'm adding. I want the total probability. So my situation is, I can find the probability of getting 1 4. I can find the probability of getting no 4s. I want the total. Either or. So I'm gonna add those.
0.8 0 3 0.8037.
I think it's 0.8. 038.
Yep. we don't convert them into like percentages.
You can, it doesn't matter, either one's fine.
On like the quiz or test, do we get like Pascal's triangle, we have to memorize all that?
You don't I wouldn't memorize it, I would memorize how to build it. So remember, how did we build it? We start with the 1 and the 1.
And you add them together.
And then every row starts and ends with a 1, and then the numbers in the middle are formed by adding the ones above. Okay, so I would definitely not, you can if you want, but I would just know how to build it, and then build it out however far I need to build it.
At least 1/6.
Alright, now this one is a little trickier. What does at least 1/6?
It could be 1 or more. You can roll 6 to 1 or more
Let's
times.
talk about that. You could get 1/6,
2 6s.
or 2/6, or 3/6, or 4/6, or 5/6. Would you agree with that?
We have to get.
That is a lot, because you would have to do each one of these situations and then add them all up, which you absolutely can do, but I want you to go in the back door. If I want to get at least 1/6, what do I not want to get?
5 6 5. You don't want to get.
I don't want to get no, oh, that sounds terrible. I don't want to get no 6s, right? That is the only option. If you look at all the options, when you roll the die, you could get no 6s, 1, 2, 3, 4, or 5 6s, right? At least one is all of these, right? That's not a 16, it's 1/6. 2 6s, 3 6s, and so on. So this is what I want. All of that's what I want. The only thing I don't want is that one. So what if I found that probability and subtracted it from 1? Would that give me the rest of the line?
Yeah.
Doesn't the whole line have to add up to 100%?
Yeah.
1? So if I can find what I don't want, then what I do want is 100 minus that, in terms of percentages. So no 6s. That means I'm gonna have no 6s and 5 not 6s. So the probability of a 6 is 1/6, and I don't want any.
And then 5 6.
A 5 is 5 6, and I want 5 of those.
2.4.
And how many ways can that happen?
1.
1.
0.4088.
Yeah, I have seen that number before, 0.40188. That is not the answer though.
Yep, okay.
That's this right here. So to get the rest of it, I have to subtract, 1. So 0.59812.
Do we keep it negative or
What?
never mind?
You're subtracting it from 1, so no, the probability will never be negative. All right, I can tell that some of you are still lost. So let's do this next sentence, see if it helps a little bit. Suppose for a minute you don't prepare and randomly guess on a 10 question. So we're gonna have 10 questions this time.
So should we keep the Pascal triangle? Oh,
We can.
and make the triangle longer.
Okay, so we have 10 questions. And, each question has 4 options. So what is the probability of being right? When you guess at this question, the probability of being right is what?
1 and 4.
1 in 4. So the probability of being wrong is 3/4. So there are my 2 probabilities this time, right, wrong. Okay? Now, I want to get exactly 7 correct. So that means in terms of probabilities, I have my 1/4 7 times, and I have my 3/4 3 times. Because remember, I'm doing 10 questions. So all 10 have to be accounted for. So 7 are correct, 3 are wrong. Now I have to figure out how many ways that can happen. So I thought we talked about this last time, but maybe we didn't. There is a connection between Pascal's triangle and your combinations numbers. Did we talk about that?
Maybe
No?
did.
Okay, well, let's talk about it now. Take out your calculator and do, just for fun, do 5C3. This is nothing with this problem. Do you remember this? What is 5C3?
10.
It's this number right here, because this number is 5C5, 5C4, 5C3. So if I don't wanna write out the 10th row of the triangle, which you absolutely 100% can do, just keep going, just don't get very big. You can say, okay, I don't know what the numbers in the 10th row are, but I can find them by doing 10C10, that would be the first number. And then 10C9, 10C8, 10C7, and so on. Now I stopped there because this represents 10 questions getting all 10 right. This is 10 questions getting 9 right. So the one I want is this one. 10 questions, getting 7 of them correct. So that's the number that's gonna go out here in front. You have 3 parts to the problem. You have the combinations of answers to the question, which ones you're getting right and wrong. The probability for right, the probability for wrong. This will be the answer to the question. So see if you can remember how to type in your combinations. Oh my goodness.
What are the chances?
If I type this in right, not very good. I got .0031.
Not possible.
Let me type in that again just to make sure.
Yeah, that's what I got.
That's what you got too, Joe?
Yeah.
So what does that mean? That means you have about a 0.3% chance of getting 7 right if you are randomly guessing. Not good. Not good.
Okay. So then the 0.3% chance of getting it all.
All right. Let's do the same thing, only this time at least 9 correct. At least 9 correct. What does that mean? At least 9. You could get 9 correct, or, so 9 right, or 10 right. So those are the 2 cases?
Yeah. Wouldn't it just be double the last one?
Now, or what does 9 right look like?
10C9.
10C9,
1/4.
10 questions, 9 of them right. Times the probability of a right
1/4 to 9.
to the 9, and 3/4 to the first. That is easy to forget. Remember, you're answering 10 questions. So if you have 9 right, you've got to have a wrong one in there. Or, so I'm going to add 10C10, 1/4 to the 10. Now, if you want to include the 3/4, it's okay, it should 0. gonna be very
It's
simple.
impossible.
Nothing is technically impossible.
That sounds like
Right.
very inspirational. 2.72 to negative 11.
So 2.9564 times 10 to the negative fifth is the total answer I added.
Why'd you do?
Oh, I
10
multiplied together.
No, they get added.
Yeah. Why'd you multiply 10 to the negative? Never mind. Scientific notation is it?
It came out in scientific notation.
Oh, yours does that?
You can have a chance to get all right.
I mean, it's damn.
A chance is a change.
It's a chance, but I wouldn't bet my allowance.
Oh, yeah.
Okay. At least one correct.
One or more. So
That
Ten-
means
10C1,
one or
10C1.
1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. Oh my gosh. That is a lot.
is that 1 factorial?
So go through the back door. What is the only thing you don't want to have happen?
0.
You know, yeah. So find the probability of getting none correct. And then if you subtract that from 100, doesn't that leave you with everything else?
Yeah.
So we are going to take the
10C0.
probability of
10C0.
none correct. So 10C0, 10 questions, none correct. 1/4 to the 0,
Yeah.
3/4 to 0.
and no,
3/4 to
3/4 to the 10.
Oh, 'cause you
Find that and then minus
And
100.
take 1 minus that, that's exactly right.
I'm getting it now.
That is way
That makes my
easier.
I got it. Yeah.
What'd you come up with? You wanna get at least one correct.
It's 0.9, it's 94%. 0.9437.
0.9437, yep, so you have about a 94% chance of at least getting something right.
Yeah, I got 4.
It's a pretty good chance. 10%. I'll take
Yeah, but then the one time you throw $100 on that, you lose it all. That 5%.
Alright, here we go. The other day, we talked about how your calculator will do combination problems, but unfortunately, it won't do them when there are letters involved. So, let's take a look at problem 6A. This right here is the same as this. So when you see things, and you'll see this a lot, that you take finite. When you see things in this parentheses like this, written on top of each other, that is a combination vocabulary. That's the way we write combinations, an alternative way. All right? Anybody remember the combination formula?
Was it like something in over?
Well, it got the factorials in it. I thought we talked about it. I can't honestly remember. Yeah, we did. We evaluated by hand back in an earlier section. So the formula for this, the one we did, I think we did something like 6C4 or something.
Was it in
And
factorial?
it's 6 factorial over 2 factorial, 4 factorial. Remember that? We did talk about it. It's in there. So your calculator would just do that for you. So you would have no reason to work this out by hand. You can just type that in. Your calculator won't do this. So you need to know what that means. So it means n factorial over what? Can you tell? N minus r factorial and r factorial. So this number goes on top, then we subtract them, and then we put that one in. Alright?
That was so crazy.
Okay, and we have to show that that is the same as, so I'm gonna stop right here for a second. We have to show that that's the same as this. Now, what would this be? According to our formula, what would this be? You guys, you can't just tune out when stuff gets a little bit complicated. You gotta stay focused.
Yep, I'm good.
What is it? What does this say? What is my formula for this?
What we?
I start with n factorial,
over,
and then I subtract them, so that would be n minus r, and then c,
And then R.
and then n minus r factorial. So remember, it's that on top, subtract them, and put that in. Now, what does this equal? I think that can be cleaned up. What is n minus
2n plus r.
n minus r?
2n plus r.
no,
Wait.
n squared minus
Oh.
r.
Yeah, just r, just r.
Oh, yeah,
This
this
is
is
just
r.
r,
Yeah,
it's
that's just
n
r.
minus n plus r,
Yeah.
right? Isn't that just r?
Yeah.
So when I clean that up, it's n factorial over r factorial, n minus r factorial. Wait a minute, wait a minute. Wait a minute. Isn't that the same thing?
So it's like a proof.
It's like a little proof, yeah. They are the same
You're
thing.
joking, right?
They are equal to each other.
I'm not doing personal.
You are dead in the water if you do not remember that, for example, xcy is what? X factorial over x minus y factorial, y factorial. As long as you know that, you can do these problems, no matter how hard they get or how confusing they look. Let's look at the next one. What does this mean? N2, so that's the combination of n things that you do at a
Okay, I
time.
get it.
So what would that be?
That would be
N factorial over
And minus 2.
n minus 2 factorial, 2 factorial?
Yeah. Got that.
All right, now I am adding to that n plus 1, n plus 1. All right, so what's that one going to be?
n plus 1 factorial
That one's gonna be n plus 1 factorial
All over 2
over
minus.
n minus.
over n plus 1 minus 2 factorial
And then 2
and
factorial.
2 factorial. Now, we need to simplify it. So who remembers what n factorial means? What does 5 factorial mean?
5 times 4 times 3.
Okay, so start with the number.
Yeah.
And then multiply by 1 less,
So you
just
get to
drop
1,
it back
yeah.
down. So what would n factorial be? Start with
N times
n, and then n minus 1,
Uh,
and n minus 2. And I'm not gonna keep writing, but you get the idea, right? That's this. Alright, what's this one?
n minus 2.
Start with n minus 2,
And then n minus 1.
no,
Oh, then minus
Down.
3.
so the next would be n minus 3.
Oh,
And so on, I'm not gonna keep writing. And then 2 factorial is just 2 times 1, or 2, I'm gonna put it out here in front. Now, what happens here, this is just this fraction I'm looking at, what happens?
Cancels out. So it cancels out.
Everything from n minus 2 down cancels. So what I have left from the first piece of the problem is n minus 1 over 2. That's what this becomes when I cancel out all the factorial parts. Okay. Now what about this part? What does this become?
N minus one, just N.
N plus one, and then N,
Then minus one.
and plus one, and then N minus one, N minus two, and da.
The bottom's N minus
And the
one.
bottom, let's clean this
N
up.
minus
What is N plus one minus two?
N minus one.
That's N minus one factorial?
Yeah.
Which will be N minus
To
one,
the N minus two.
N minus two, and so on.
So instead of 1 over 2
And
factors,
then two,
so N squared, it'd be 1 plus N on top.
so everything from that's gonna cancel, is you agree?
Square plus.
N.
So we're left with N plus one times N over two.
Yeah. You don't simplify that?
No.
Now wait, remember, we had two parts. This was our first piece, and this was our second piece. And we are supposed to be, they're not equal, they're not the
No,
same
they
thing.
equal N squared, both
But
of them
no, we're gonna
added.
add them
Yeah.
together. So I'm gonna
And
take
add
that
equal
one
squared.
and add the first one. They already have a common denominator, so that's good.
Yeah.
So this is N squared plus N. And this is N squared minus N.
Can you
Cancel
combine
ends.
combine like terms?
So these are gonna cancel,
So it's
so
2N
two N
So just N
squared
squared,
over
yeah.
two, which is
Squared.
exactly what we wanted. Awesome.
A lot.
It is a lot, but it is fun
Yeah,
I
so
get- I
I'm
get
actually
that.
like having a lot of fun.
and very, very logical.
Hey,
So,
A little bit.
okay, so before we go on, I want to do, I'm gonna back up and do one more problem with you to make sure that we have it. Yeah. Patton,
Yeah.
quit watching the clock, man.
No.
Yeah.
What?
Is it your birthday? Close to your birthday?
It's already.
Really past your birthday? Okay, here we go. We give you a quick review, two quick reviews. Simplify this for me. Right now, I want you to simplify this. So using what we were just talking about, just simplify that. So expand it out using your formula and then cancel. Anything that'll cancel. Tell me what you're gonna get. Joe, it's not a movie, you can't fall asleep.
Okay, so,
N factorial over N minus one factorial.
Exactly, this
And then-
is, if it helps you to write it this way, that's okay.
yeah,
But it's N factorial
over
over N minus one.
Factorial, negative one factorial.
N minus N minus one,
Uh,
right? You subtract them.
oh, yeah.
So, let's clean that up first, is that what is this equal? Is that just one?
Yeah,
So that's just one. What's this?
N minus.
N,
N minus 1, N minus 2, minus 3, blah, blah, blah.
what's this?
N minus 1, N minus 2. Stop.
What's one factorial?
one.
1.
One. So what am I left with?
N.
N.
You didn't give us a given though, did you, right? You didn't give us like what we have to prove.
No, I just said simplify that.
Oh, okay.
I just wanna make sure you can simplify that. And that would just simplify down to N. Okay, the second problem I want to do is this. Let's suppose, well, actually, it's true. In my stepmother is the oldest of 10 children, 9 girls and 1 boy. So what is the probability that if you have 10 children, you would have 9 girls and 1 boy. What is that probability? Now, remember, this is right or wrong, true or false, boy or girl,
10C9.
right?
Wait, you
This
can
is-
do 10C9.
So, 10C9
Or 10C1.
or 10C1,
Yeah.
they're the same, they equal each other. So I'm gonna do 10C9, that's, I have 10 kids, 9 of them are girls. Now, what are the probabilities? The probability for a girl is 1/2, and I want 9 girls. The probability for a boy is 1/2, and I want 1 of those.
But this is like, this gives the criteria because they don't identify it.
Stop.
Dana,
Stop.
Nick.
Just-
It's a gray area, we're in a
I
gray
can't handle it, I can't handle it, just, let's just
That is a
assume
good
we don't
question.
identify. Alright, so what do we get? I get .0098, so there is less than a 1% chance. It's almost 1% chance you would have 9 girls and a boy. Okay? Alright, see how that works?
This is tough.
Oh, let's do one for Joe, because he's having a hard time staying awake. Joe, what is your batting average? The pitcher's not bad?
No.
Okay, make up a batting average.
320.
That's .20, right? Okay.
That's somewhere,
That's not that hard, guys.
yeah, that's somewhere in your range.
Alright, so the probability, and I don't know all the nuances of baseball, so I'm just gonna say the probability of Joe getting a hit is .320. That means the probability of not getting a hit would be
780.
point, no, 680?
Oh, my bad.
Point 680?
You're good, 680.
Now,
You're good. You're
let's
good.
let Joe go to bat 6 times. So he goes to plate 6 times.
It would make more sense.
What
to get
is-
probability
6
of
times
the
0.32.
What is the probability, we want the probability of exactly 3 hits,
Okay, I got you.
okay? So we are finding the probability that he will get a hit half the times he goes. 3 out of 6.
6C3.
So we start with 6C3. Now why? Because he is batting 6 times and we want 3 hits. His probability of a hit is .320 and I want 3 of those. And then his probability of not a hit is .680 and I want 3 of those. Is this starting to make a little more sense? So now I can go to my calculator. 6C3 times .320 raised to the 3rd times .680 raised to the 3rd. So I got .206.
Yeah.
So there's a little more than a 20% chance that he will do that.
Wait, why'd you pick the 3? Oh, it was actually 3 hits.
Alright, 9-2 homework due on, what's today, Wednesday, Friday. So 9-2 homework is due on Friday. Moving on to 9-3. Non-mathematicians will often use probability and odds interchangeably, but they do not mean the same thing. If you say to me, Mrs. Ford, what is the probability that you will toss a coin and get tails? I would say 1/2, right? That's the probability. Because probability is defined as a fraction, and the numerator of the fraction is what we call your successes, that is what you want. This is probability, the number of successes in my coin toss problem. there's one tail. But there are 2 total outcomes, so that would be 1/2 in my coin toss. Probability is what you want over the total. Odds, on the other hand, if you said to me, Mrs. Ford, what are the odds that you'll flip a coin and get tails? I would say even, 1 to 1. Why are they even? Because odds are defined as the number of successes over the number of failures.
They must balance.
So in the terms of a coin toss, when I flip it, I'm gonna get a head or I'm gonna get a tail. So there's 1 success and 1 failure. Odds are usually not written as fractions, although they can be. They are normally written sideways with a colon in between. So this means if I play the game twice, I'll win once and I will lose once. If the odds are 1 to 2, that means if I play the game 3 times, I'll win once and lose twice. So odds of 1 to 2 are the same as probability of 1/3. Because I'm playing the game 3 total times and winning once. All right, do you see the difference? You gotta read your problem carefully, because that's gonna determine how you set it. What do odds of 3 to 2 mean? 3 to 2. What does that mean? No, if I
Wait,
play
3
five
times
times.
1, 5
Five
times you
five
win,
times.
2 times you lose.
Oh, 3 and 3.
Wait, no, that's
All right. Maggie has a bag of M&Ms, as does Elizabeth. Each girl has counted the M&Ms, discovered the following proportions in each of her bags. See the chart below. Okay. So what that means is, just so you're clear,
I'm all up.
Maggie has 30% green. 30% green for Maggie, 20% yellow for Maggie, and so on. Notice that all the percentages add up to 1. They gotta add up to 100%. Okay. So if a candy is chosen from Elizabeth's bag, what is the probability that it will be green?
I mean,
From Elizabeth, it would be 20%. 0.2. Feel free to use decimals or percentages or fractions, it doesn't matter. 0.2. What is the probability that if Maggie picks one from her bag, it will not be yellow? 80%. Because the yellow for Maggie is 20, everything else then has to be 80, right? So 0.8 or 80%. If a candy is chosen from each bag, what is the probability that they will both be red? So in other words, you want red and red. All right, you want red and red. So let's do each one individually. What's the probability that Maggie gets red? 0.2. What's the probability that Elizabeth gets red? 0.3. Now wait, guys.
No, but they both
Wait.
did. Yeah,
25%?
chances that they both did it or not.
Oh,
Very good, Sam. Your logic is good. You're reasoning it out. Now, I want you to listen very carefully to the problem. This isn't Maggie gets red or Elizabeth gets red. That would be 0.5. Because if it's an or, you total them up. This is an and.
they both.
What do? Multiply, absolutely. When it's a multiply, so when it's an and, you multiply. So the answer will be 0.06. watch that decimal,
6%.
0.06. Now, I don't know if you were listening to Sam, but when I had the 0.2 and the 0.3 up here, somebody said a number like 0.5 or 50%, and Sam said, no, wait a minute. That doesn't make sense, because if Maggie's probability is only 0.2, then the probability of both of them doing it can't be more than hers.
Yeah.
Doesn't that make sense? So that will multiply, so it's 6%, 0.06. All right, how about D? Neither will be brown. So not brown and not brown.
0.9
0.8
times 0.9. Yeah.
0.8 times 0.9, so 0.72,
Yeah.
not brown. Everything but brown. Bless you. All right, so probability that first one is green, that is 0.3. And the second one is blue, that will be 0.2. So 0.3,
0.06 again.
0.06 again, yeah, 0.3, 0.2. First bag is Maggie's, second bag is Linda's. All right, now what about F? F. The candy's chosen from each bag. What is the probability that one will be blue and one will be green? Now be careful. Exactly. Because this could be, there's no order. So this could be, we get blue and green, or we get green and blue. Would you agree with that?
Yeah.
So let's do blue and green first. So that would be 0.1 times 0.2, or 0.3 times 0.2. Now look at my numbers and see if all that makes sense to you. So this one's 0.02. This one's 0.06. So the answer is 0.08. The difference between problem E and problem F is problem F has no order. All right, last one, then I'll quit. G. Candy's chosen from each bag. What is the probability that neither will be red? Neither red.
0.8
0.8
times
times
0.7.
0.56.
As we head into the March Cherry, let us pause to be mindful of all of God's blessings.
Good work, folks.
In the name of the Father, and Son, and the Holy Spirit. Amen. Lord, give us
Hey, we're praying. I should hear my puppy. Is it this which you have received from the Lord? Enjoy your lunch, folks. I'll see you tomorrow. Some fun and excitement. So, Joe, aren't you glad you came to that today?
Yeah. It was a good movie though. I was watching Precal.
Oh, yeah.
So what class is that?
I was just got my mom wanted me to watch it. No, I had research.
Oh, okay, okay. You could have been doing some math homework doing resource.
I did the homework.